Before we proceed further, deeper into metaphysics, let's perform a quick reality check. Here is Christian Kurtsiefer again, one of those people who took Bennett's, Brassard's and Eckert's abstractions and made them usable. By the way, he is also one of those who proved that we are not living in, as Clint Eastwood would say, a perfect world. How difficult is it to build a machine that sends entangled photons and distributes quantum keys?
Actually not too difficult anymore, but there was a huge development over the last 15 to 20 years that brought these systems from a lab-filling monstrosity into something smaller units, and nowadays you can fit this whole thing into essentially a Coke can. So the basic components you have are probably not that different than what you find in a CD player. So you have diode laser systems, a few crystals and optical components to it to make entangled photons. You can then send these photons to various places using either optical fibers or telescopes if you want to just go through free space. And at the other end you have photodetectors which receive these single photons and do measurements on these photons to finally come up with a cryptographic key. Our job was essentially, or our challenge was to bring that system from a demonstration experiment to something that looks more or less like a practical system. So you build units that actually work and generate a key. Now on that journey you find out there's a lot of challenges to bring a theoretical promise of having a secret key into really practical systems. And you also find some shortcomings on that way that you need to overcome practically to make that system as secure as you think it is from the theoretical description.
So you are the guy who goes there, takes very theoretical abstract things and put them into practice, into practical things. But then you come back and show that it doesn't really work.
Well, that's our job, okay? So if you have a strong claim that you can generate a secret key, you need to test all the challenges that make questions such a physical system, and that's the job as a physicist, that you constantly query what you do, and you're not satisfied with something working on paper. You just have to show it in practice.
If you have the impression that quantum cryptography somewhat failed, it is not correct. Despite inevitable implementation loopholes, or maybe thanks to them, at least partially, quantum cryptography is a lively field. But it is not the mythical, totally secure method some would like it to be.